Signal Hounds talking RF, and today we're talking how to control Signal Hound devices with our API using Python.
This is Signal Hounds talking RF. Sean here, and in this video, I'm going to show you how to control our devices with our API using Python. Many of our users will find that our FreeSpike software contains all the features they need. However, some customers need custom features such as integrating control of a Signal Hound device into their own application. These types of customers can utilize our SDK to meet their needs. Our SDK offers the customers the ability to control and extract data from our devices using our API or our SCPI commands. Our API is written in C++. For customers looking to use another language like Python, we do provide wrappers for interfacing with the C++ API. For this demo, I will be using an SM200C, a laptop, and Visual Studio 2022 Community. Let's get started.
First, we need to have something interesting to listen to. We're going to use the VSG60A to input a 1 GHz CW. To download the SDK, go to signalhound.com, Software, SDK, scroll to the bottom of the page, and download Signal Hound's SDK. Once it is downloaded, extract it. Once the SDK is extracted, you'll have the SCPI folder, SHR parser, and device API folder. In this demo, we're going to be looking at the Python examples that will be in the device APIs. Since we're working with an SM device, you're going to want to go to SM series, examples, Python. Now in the Python folder, you can see there's a README. That README contains information that you will need to understand how to install everything correctly. The SciPy and NumPy packages will be required for some of the examples. We have an SMAPI.dll, which needs to be placed in the SM device folder. Now you'll get the DLL, go to SM series folder, then lib and Windows, and we're doing all of this in Windows Visual Studio 2019 version x64. Copy this. Next, go back to Downloads, click on the folders, Examples, Python, and place that DLL in the SM device folder. Now you should be able to run any of these Python examples using whatever IDE you like to use or command line. Right-click here and open the Visual Studio code. This is the sweetplot.py. We chose this because this will give us a nice GUI output. For this demonstration, use the Python examples. Press play and debug. Looks like we have a couple of bugs. One of these issues is the sweetplot example, which uses an SM open device for an SM200B. We are using an SM200C, which is connected over the network. We will grab the SM_open_network_device function from networked_speed_test.py example found in the same folder as the rest of the examples. An additional bug that needs to be addressed is going to be the sweepmax on line 52. That does not exist. What it means to reference is sweep_max. Now run the debug to see if we catch everything. You can see that we are tuned to 1 GHz and we are injecting a signal at 1 GHz just like you'd expect to see. That is the Python example, which is straightforward and set up for the user.
Today we learned how to control Signal Hound spectrum analyzers using Python. If you have any questions, please contact us at support@signalhound.com or leave your questions in the comments section below. Like, follow, and subscribe for more Signal Hound and RF content.